Good afternoon. I'm audible. Dear participants, I'm audible to you.
Yes, sir. Yes, sir. Yes, sir.
Thank you. Thank you. Thank you. Okay, I think we should start our session. So, welcome you again in this fourth day of the FDP. And the topic, as per the timetable was given, as the schedule was given, if you try to remember, there was a topic. Mm, Let me open the schedule. Whatever the schedule I have discussed with you. Yeah. So, you see the last day, session number 14. There was a topic EDA, artificial grouping, concept, application, and K-means. This is the topic I'm going to cover it. So that is the title of the topic. Typically, we are going to discuss about the descriptive data analytics. Under the descriptive data analytics, we will cover the K-means clustering. So the background, let me explain each and everything. We know there is two kind of category of the algorithm broadly you can define like unsupervised learning and I think supervised learning. So everybody are now familiar all this terminology. In the supervised learning, there is a classification and regression. Each and every example we have seen under the algorithm like classification, we have seen the logistic regression, and in the regression, we have gone through the algorithm in detail. We have studied about the linear regression. So we have seen the nature of the classification kind of problem. We have seen the nature of and characteristics of the problem that comes under the regression. Now the one category is left out. So today I'm going to cover it. In the unsupervised learning, one type of one subcategory of under the supervised learning is the clustering. I hope everybody have listened this word earlier. Under the clustering, many algorithms are there. Here I will cover the K-mean. Very interesting a discussion will be, and it's a small example through I try to make it clear, and with a numerical I also try to make it clear whole working of the K-means clustering. So that is the topic here. We are here today descriptive data analytics and the clustering you can say. So if I say directly from the Wikipedia or any other book if you refer, what is the clustering? So as we know, the clustering is an example of descriptive data analytics, is an example of unsupervised learning. So easily, in a one way, in the one line you can answer is clustering is unsupervised descriptive data analytics because we know the meaning of unsupervised, we know the meaning of descriptive data analytics. Under the descriptive data analytics, we used to describe the data. We used to find out the pattern. We used to find out the trend that is hidden inside the data. We are not here to predict something. That's why it is unsupervised learning. Technically, there will not be any guiding parameter, means there will not be any target variable, any output variable will not be there. So that was the fundamental difference between the supervised learning and unsupervised learning. We have already seen in the previous lecture. In the supervised learning, there is no target variable, there is no output variable. So that's why it is called unsupervised descriptive data analytics. Definition talk about clustering is a process of, or clustering is the task of dividing the population or the data point. In statistics, data set is called the population. So the clustering is a task of dividing the whole data set or data point or samples in a number of groups such that data points in the same group are more similar than the data points that belong to the different group. So ultimately, we need to divide the data. We need to categorize the data. Okay. During the categorization, we will create the small groups That group will contain some data set. And the what will be the property? If you try to see the property and characteristics of the data point that is a member of the same group will be similar to each other. Then the data points that belongs to the another group. That is a whole sole objective of the clustering process. There is some important point need to be discussed over here. Those points are
Audible, sir. Any problem?
Hello, I'm audible. Something happened in between. Sorry, I couldn't listen you. I'm audible.
Yes, sir, you are audible.
Oh, something happened. I don't know what happened. Okay. Okay, let me again reshare the things. I think the network was down from my side. Okay. So sorry for the interruption and hope my screen is visible to everybody. My screen is visible to everybody. Yeah, thank you. So I was saying once uh, uh, I've created cluster. Oh, there's two clusters presented through red color cluster, blue color cluster. Red color clusters are set of all those customers who used to purchase whenever they visit about the electronics items. And the red blue color clusters are those customers that used to visit to purchase the daily usable item like a grocery or something else. So once you know these are the group of customer based on their characteristics, you can give the name, you can give the label like a electronics item lover either is the name of that cluster and the grocery item lover is the name of different cluster, another cluster. So that is the meaning of that line. While doing the cluster analysis, we first partition the data set into the group based on the similarity and then assign the label to the group. I think that thing is clear to everybody. So once the cluster has been created, there is a no label, there is a no name. But data scientists used to see the property of the data point that become a part of the cluster, what kind of property, what kind of attribute they have. Based on that, they can give the label, they can give the new name. And these new label can become a new feature. So once after the clustering it's many time happen, you may feed that information for the classification purpose. So the output of the clustering maybe become one of the input feature for the classification. Okay. So that's why saying it's make a kind of features. One more important discussion you're supposed to understand. Many of the time the newcomer understand in the clustering process we usually going to divide your data point physically. We are going to create a group physically, not at all. Very important things, make it clear. In the clustering, we don't touch the data at all. We don't move the data at all. You see that you can reconfirm this property by seeing this example. Suppose left hand side is given a set of data point. Let me enlarge it. Yeah. So after the clustering process, the three cluster has been created. Suppose that is a green color cluster, blue color cluster, and the red color cluster. So what the important thing I want to make it clear, you see the relative distance among the data points. So the way the data was distributed earlier, after the clustering, the data points were not moved here and there. The relative distance among the data point is intact. They are same. So ultimately, we are not changing position or distance here and there any of the data point during the clustering process. Okay. If it is true, then how we are saying we are making the group of item. So I can explain with the example, very important part. Suppose this data set is given to you. Suppose age, weight, salary. This is given to you and data points are like that. This Excel site, Excel or tabular data you can consider. Okay, very simple. In real life, it happen in the programming or in the implementation. It happen like that. So many of the time if you ask the people or student what is out of a clustering process, so that you need to understand. Sorry, sometime this editor create a problem. I have to change it. Wait a minute. Yeah, suppose this is the weight, this is the salary. Okay, so suppose this is the data set is given to you. That data set easily you can visualize. So these are the rows, maybe thousand millions of rows are there. Okay, this is the data set. Or as the day one we are discussing, this one row is a one data point. One data point. One data point. This is second data point, and these are the n number of data points. Okay, so suppose visually we can represent this is the data points that are you can imagine, and hope the two cluster you have created or three cluster you have created. Suppose so this is the one cluster, this is the another cluster, okay, and this is the third cluster. Okay, so suppose three cluster we have created. This is C1, this is C2, this is C3. So what happened actually, once the training process is over, it create a new column. That's why we have written over there the new feature has been created. So it is called cluster. So if the data point 1 is belong to the cluster 1, we say C1. If second data points also be a part of cluster, then C2. If it C1 suppose, and third data point is a cluster of part of cluster 3, cluster 3, cluster 1, cluster 1, like that. So ultimate end of the clustering process, whatever the data set was given to you, you will see one extra or new feature has been included with the name of cluster, or it's up to you whatever the name you want to give. And these data points belong to the which cluster ID will be given over here. Here cluster ID I am representing with the C1, C2, C3. You may represent with the 1, 2, 3 or whatever the name you want. Here C1 maybe electronics item lover, C2 maybe the grocery item lover, C3 maybe something. Okay, so this is the real picture that you need to understand what happened after applying the clustering process. It never going to touch the data point physically, it never move the data point here and there. Instead, it create a new feature, and that new feature talk about the new label or category or group item, or technically the cluster ID where the data points belongs to. This thing is clear to everybody. It's very intuitive, very simple, but most of the time we don't understand really it happen after string process.
Actually,
It is
cluster
clear to
ID,
everybody?
excuse me, sir, but
Yeah, please.
actually cluster ID will be differentiated by the age, weight, salary. Three factor will be based upon the cluster ID will be identified.
Hmm.
Okay.
What is question I'm not getting?
What I'm asking is the cluster ID also changed uh, based upon the age, weight, and the salary.
No, whatever the clustering process you apply, you see that this is the output of the clustering process. If these all data points be a part of cluster 1, suppose, so their ID will be a cluster 1, cluster 2, cluster 1, cluster 1, ID 1, ID 1, ID 1. If these data points belong to the cluster 2, then we have to write the cluster 2, or system will designate their cluster ID. So based on the characteristics, yes, easily if you are purchasing the most of the time electronics item, then you will be marked as electronics item level cluster automatically. If you are purchasing most of the time grocery related item, automatically the system will place you into the different cluster. So it's depend on the sales value. Yeah, what kind of value is the age, weight, and salary. These are the feature. Based on the feature, divided.
Just for example, that's all. Right?
Okay,
Am I
got
right?
it, sir?
Got it. Okay,
Thank you,
sir.
thank you, thank you. Any other question and doubt if you have, please? Okay, so I should go ahead, I think. That thing is clear now. Uh, but we know, yeah, the process is given, the output is given. We want to be a cluster and the data points within the cluster having the similar property. But without objective function, how the algorithm will work? So these are two objective functions are there. Based on those objective functions, the system will try to drive the this clustering process. So what are those two? Let me 1 minute. Let me open it. Yeah, yeah. So what are those objective function? First point within each cluster are similar to each other. That called intra-cluster distance. Try to understand the terminology. Intra-cluster distance that we want to minimize. So if the data points are so much close to each other within a cluster I'm talking about, this means cluster are homogeneous. This property we call homogeneity. So ultimate my objective is to increase the homogeneity. Clustering is an iterative process. Sometime you can consider. So in the iterative process, every time it will create some cluster and we'll see the homogeneity. Then we make some changes. Then again we have to check the homogeneity. If the homogeneity is increasing means our system or algorithm is working on the correct direction. What is the homogeneity? Means within a cluster, distance between the data point is called as a homogeneity, and another word is called intra cluster distance that I want to minimize. When the distance between two data points are minimum means they are more homogeneous. Opposite is also true. Second objective function is that data points that belong to the different cluster, that is called intercluster distance, that I want to maximize. It is called heterogeneity. Means if two data points be a part of same cluster, I want similar. If two data points belong to the two different cluster, I want them most dissimilar. So that's why if two data points is a part of two different cluster, the distance between them to be maximized. It is called heterogeneity. So two data points or data points that belong to different cluster must be different. Otherwise, what is the meaning of making of two cluster? The concept behind it you need to understand. Why we want more heterogeneity means more different data items that belong to the different cluster. It is true if the data items are not too much different, if they belongs to different cluster. So what is the meaning of creating the different cluster? We should combine it. We should merge that cluster. So that thing is clear. These are the two objective functions. So graphically, we can understand what is the meaning of that. Suppose the whole data set, you consider the whole data set. Okay, this whole data set you apply the clustering process, the three clusters are created. Okay, you see within a cluster, you have seen this distance between these data points. And we will try to minimize it. We try to make the very dense cluster so that all the data points share the same property. So if I try to interpret meaning of the distance talk about the data points are similar or not similar. If two data points are very close to each other means they share the similar property. If all the data points are very close, very dense and making a very close group means all the data points having the same property. Means all are purchasing the electronics related items. All are purchasing the grocery related item. They are more similar. Opposite is true. Why? If the data points you see over here, these are the one cluster and that is another cluster, and you try to see the distance between two data points belong to the different cluster must be far distance. Means the nature, property and characteristics of two cluster ideally must not be similar, otherwise merge it. So this thing is clear to everybody, very intuitive, very simple, I think so. So the idea behind the whole clustering process, I think it is clear to everybody. Okay, any question please ask, otherwise I will go ahead.
Yes, sir. Proceed,
Okay,
sir.
thank you. So I will not go much about the clustering applications. Clustering is used, I think, all the way, all the area that you can imagine. It start from market analysis, pattern recognition, data analysis, image processing, market basket analysis, customer behavior pattern, customer buying pattern understanding, and taxonomy. If you want to create maybe a plant taxonomy, animal taxonomy, the clustering will be there. Geospatial applications are that where you need to analyze the geospatial images, the raining pattern or a flood pattern you want to analyze through the data points. So through the images, the clustering will be there. The google.com is the most prevalent and most simple example for understanding the clustering process, how the Google work is. It is a typical clustering is happening behind that one, how they are classifying or how they are creating the group of documents in the web with the type of clustering, outlier detection applications, anomaly detection applications, and many ways. Means you can think about clustering is everywhere. So everywhere you will see the application of the clustering. So I will not go in much detail what is the clustering applications are there. Consider that application, there's wide applications are the clustering. So our objective is to understand the working of the clustering, and how can we solve the problem by using the clustering. So in that direction, the clustering is a complete branch of descriptive data analytics, one of the branch. Under the clustering, so many subcategories are there, not algorithm. So many categories are there, like partitioning based partitioning based methods or the one category. Hierarchical based clustering is a one category. Density based clustering is a one category. Similarly, many categories are there. So don't think there is only three category: partitioning based method, hierarchical method, and density based method. There are many more. Okay. And similarly, under that particular category, there are many algorithms. One of the famous algorithm that comes under the partitioning based method is the k-means clustering algorithm. In a hierarchical method, there is agglomerative clustering. Density based method, DB scan is so famous. So here, that you understand, based on the process that you need to adopt to make the clustering can be different when you go with the different methodology. So partitioning based method work in the different methodology, hierarchical clustering work on the different methodology. Similarly, density based method like a DBs can have a different way of working. So with the limited time, we cannot cover all the methods. So but we need to start somewhere. Then I'm just picking a partitioning based method. Under the partitioning based method, I will pick up or I will explain the k-means clustering. So what partitioning based method talk about? It talk about, suppose there is n number of objects are given, n number of data points are given, and your objective is to partition those n number of data points into the k cluster. So k number of partition you need to make such that each partition will be present the cluster. So total number of partition will be less than n. I think everybody agree. If n number of total data points are will be given to you, then you may create the cluster k number of cluster where the k will be always be less than or equal to n. This everybody is agree with this condition. And total number of data points are given to you. K means number of cluster or number of group you have to create. So mathematically, the number of group can be bigger than the number of data points you have? I'm asking this simple question. If you are listening easily, you can answer it.
Agree with sir.
Okay, thank you. So I must say it is not a correct answer.
Because of,
So
for example, we are having three fruits, apple, orange, mango.
yeah.
When we categorize
Yes.
to the three category, we have to classify the three cluster.
Okay.
Okay,
So means
we have a three fruits. We have to classify into three cluster. So number of cluster also less than or equal to k, sir. So
okay,
that
good
is to,
idea.
yes.
Very. Other participants are agree with the reasoning given by the sir. So means number of cluster cannot be more than the total number of data point. Yes or no? This question may be your MCQ question next day. Okay. So answer is wrong. Okay. You should in the machine learning you should not try to answer it immediately. If you are confused, you should make it clarify. Then you try to answer it. How? Oh, wait a 2 minutes, then I will pick up again this question. Okay. For creating an interest, I just asked this question. So suppose I'm just agree with this condition. K is less than n number of data point. It means that it will classify the data into the K group. Agree with that, which satisfy the following condition. So these are the conditions that you need to satisfy when you apply the partitioning based method. What is the condition? Condition means each group contain at least one object. Means there will not be possible a cluster or empty cluster. Okay. If there are cluster that don't have any data points, so what is the meaning of that cluster? So we required a cluster that have at least one data point first. Second point is more important. Each object or each data point must belong to exactly one group. It is called hard clustering. So when I talk about the hard clustering, that you need to understand what is the soft clustering. So here I will explain the hard clustering and soft clustering. Then you will be able to answer it whether k less than equal to n is true or not. So directly you cannot answer it. So let me explain what is the meaning of hard clustering and soft clustering. So hard clustering means what? Hard clustering in which talk about each data points either belongs to the cluster completely or not. So means hard clustering, the data point cannot be shared by the multiple cluster. In other words, data point will belong to one and only one cluster. It will not belong in other cluster. Okay. Where the soft clustering talk about something flexible, where he talk about, yeah, it is possible a one data point may have a membership of more than one cluster. Means a data point can be shared by the multiple cluster. So it is called the soft clustering. I can visualize this concept here. Suppose these are data points given to you. You have created the three cluster. These are the three cluster where the data points are very cleanly, completely be a part of one cluster, are not being shared by the another cluster. In the soft clustering, what happens? You can see some of the data points are shared by the multiple cluster. So this thing is clear. Okay. Now, this sir, I'm asking again the same question. Discuss with any other example. Sandesh, I'm not understanding what is the meaning of another example. I think this is damn clear. So if the data points are shared by the multiple cluster, then it is a soft clustering. Otherwise, it is not a soft clustering. With the data set, okay. So here you can understand here. Okay. So what technically it happened, try to understand. The technically things is that suppose the data set is given to you. This is the data set is given to you. Where if data points belong to the green color or circular cluster, they completely be a part of that cluster or that class. So whether the data point will be on the green color cluster or the blue color cluster completely, it is a part of hard clustering. In the soft clustering, what happens you see over here, we start playing with the probability. How? You see the border point, you see that the green color cluster he talked about, suppose there are two clusters. So what is the probability of that data point? What is the probability of that data point to be a part of green color cluster? It is 97% probability. And there is a 3% probability the part of blue color cluster. But the moment you will start moving toward to the boundary where the two cluster boundaries are very close, you start seeing that the data points that are on the boundary having almost very similar probability, similar membership value to become of both the cluster. So like this data point is 47% probability the part of green color cluster, and that is a 53% probability to be a part of a blue color cluster. Dr. Durga, Dr. Durga, Dr. Durga, are you there? Yeah. So please see your mic always whenever you are there. Okay. So something again, I'm requesting
ஆமா ஆமா
Dr. Durga.
இந்த பக்கம் ஒரு எஃப்டிபி ஓபன் ஆயிருந்துச்சு அவதை கவனிக்காம நான் எல்லாம் க்ளோஸ் பண்ணி விட்டுட்டேன் ஆமா
Sorry for the interruption. I just handle it. Okay. So that is the example of soft clustering and the hard clustering. Arundhati ma'am, is it clear now? It is more clear what is the soft clustering and the hard clustering. How it going to be implemented? It will take a lot of time to understand. Okay, so it is the just information and knowledge I have given. So now I am asking again the same question, whether the condition is true or not about this K. Now in the soft clustering, K may be a bigger than N. How? You need to understand that thing is very clearly. Suppose there are 3 data points. There are these 4 data points. So means n means 4. Now this is cluster 1. Suppose this is cluster 2. This is cluster 3. This is cluster 4. K is equal to 4. This is cluster 5. This may be a cluster 6, like that. So means in the soft clustering, you start sharing the data items. Or in a different way you can do like that. This is cluster 1. This is cluster 2. This is cluster 3. This is cluster 4. This is cluster 5. K is equal to 5. Okay. So K always be less than M if there is a hard clustering. If it is a soft clustering, there is a no rule. Okay. So it is clear to everybody. Now it is clear. I'm just asking to all the participants so that I can go ahead. Thank you. Let me start with the K-means clustering. What is the K-means clustering? So the K-means clustering, I need to understand what it is. K-means clustering, perhaps the most commonly used clustering method. I think whether you are the guy from the data science or not, but somehow, somewhere, you might have listened the name of K-means clustering. So there are various versions of the k-means clustering are there in the market. So that is the most simple version of the k-means clustering I'm going to explain. There are many various versions like fuzzy k-means and centroid k-means, centralized k-means, and many versions are there. I'm not going in that part. So some of the important key point of the k-means clustering algorithm, let me explain. The k-means algorithm assign each of the n data points to the one of the k cluster. So whatever the data points are given to you and the k number of clusters, suppose you have planned to create, randomly you have to assign data points to the clusters, where the k is a number that has been determined ahead of the time but must be given in the advance at the beginning. Very important line. That is a limitation you can say, and the condition in the k-means clustering, how many cluster that algorithm will create, you have to pass it at the beginning. Either k is equal to 2, k is equal to 3, k is equal to 4, that the user has to give that value. But as you know, the user can't understand in advance what is the natural grouping nature in the data set exists, we don't know. So suppose the natural grouping characteristics of the data is 3, means ideally you should divide your data into the 3 cluster. Okay, but we can't know, we can't understand, we are not God, so we cannot understand the k is equal to 3 is the ideal value. So you may start with the k is equal to 5 or k is equal to 2. So that may be wrong. But luckily we have a technique, we have a method that further will suggest the k is equal to 2 and 5 is not good. You should select the k is equal to 3 like that. But that method you cannot use at the beginning. Once the clustering process is over, then that method is applicable. Then you use that method. Then you have to again apply it for the clustering process again. So that's why it is written. You must be given in the advance, but you can be determined ahead of the time. Okay. Third point is damn clear in the clustering process. In the k-means clustering process, the goal is to minimize the difference within the each cluster. Means homogeneity I want to increase. Similarly, we need to maximize the difference between the cluster. Means heterogeneity we supposed to increase it. So these are the some important points you need to remember. Procedure. The k-means clustering, the algorithm I am explaining right now. The procedure is what? It is the iterative process. It is a recursive algorithm. So what happened in the recursive algorithm? The some steps will be given to you and you have to execute, you have to repeat those steps multiple times. Okay. And somehow you have to stop there. So that is called stopping criteria. So that is clear in the iterative process. If there is no stopping criteria, it will continue forever. So I will discuss the stopping criteria later. First, let me discuss what is the iterative process. So the whole iterative process you can divide into the two phases, updation and assignment. So look here, the phase is updation and assignment, updation and assignment. So you have to repeat that updation, assignment, updation, assignment, updation, assignment multiple times. Okay. So what it is the assignment, what is the updation? Try to understand. First, randomly we have to assign the data points into the k number of cluster. So that is called assignment. Again, I am repeating, whatever the data points are given to you, that you have to assign data point to the clusters. So that is called assignment process. So that assignment may be wrong or may be correct. Or it may be correct for some set of data point, it may be incorrect for some set of data points. So then the second phase, like updation, we have to check it whether the assignment, whatever I made randomly, is correct or not. For those data point that random assignment is correct, we don't need to do anything. But if some data points are wrongly assigned to the wrong cluster, we have to update it, we have to correct it. So that is called updation process. Agree? Third point, the process of assignment, updation occurs multiple times until changes no longer improve the cluster fit. So here I am explaining the stopping criteria. Every time after the one process complete, we have to check the cluster fit criteria. I will explain what is the meaning of the cluster fit criteria. If improving, we have to go into the next step. But if continuously you are repeating the iterative process, but cluster fit criteria is not improving, what is the meaning of execution? What is the meaning of continuous follow the iterative process? We should stop it. What is the clustering fit criteria? Same homogeneity and heterogeneity. So if through the one by one iterative process, my homogeneity and heterogeneity, that was the two objective function, if they are improving, we should continue. So after some time, the process or that clusters become saturated. So the clustering fit criteria will become stable. It doesn't change. So we should stop it. So that is the last point is written. At that point, the process is stopped and the cluster are finalized. I'm explaining again the process to the flowchart diagram. Try to understand it. So what happened at the start? Suppose k number of clusters are there, because the k is something that user has to define. Mathematically, you have to calculate the centroid of each and every cluster. Slowly, I'm going into the typical method. Mathematically, you can implement the clustering. That way I'm coming. So whatever the cluster you have created, you have to randomly, what the cluster you have created, you have to calculate the centroid of each cluster. Then you have to calculate the distance of all the objects. Try to understand the word distance of all the objects to all the centroid. And based on that distance, you have to change the grouping. You have to change the membership. Then go ahead. If that are improving, objective functions are improving, we have to keep on iterating, keep on iterating, keep on iterating. So means here it is written the stopping criteria. There may be a multiple stopping criteria I will cover. So here very interesting to let me explain with you with the diagram. The whole the process I am going to explain visually. Suppose that was the data points. That are the data points are given to you. Agree? This is the data points are given to you. Agree? And suppose this is the first cluster you have created, and and this is the another cluster. So this is the another cluster. So this is the another cluster. Okay, suppose there are two clusters. Agree? So this is the cluster 2 centroid. Suppose this is centroid you have created. Similarly, there is centroid for the cluster 1. This thing is clear to everybody. This is C1. Suppose two cluster I have created. These are the data points to be a part of cluster 2. Randomly I have done. Okay. These are the data point to be a part of cluster 2. It is clear to everybody? So that I can go ahead. Okay. Okay. So now we have to calculate the distance of all the data points. Try to understand what I am saying. Suppose this is the data point. This data point distance to the centroid one. Every time it happen. Yeah. So suppose this is the data point. I have to calculate the distance. This distance. It will not let me do it. So this is the data point. The distance from C1. I have to calculate the distance from C2 also. This we have to repeat from this data points also from C1 to C2. Similarly, this data point to C1 to C2. So this process I have to repeat for each and every data point. And suppose this data points also, this data point also. So suppose this is the distance D1. I am just focus on one data point and the process will repeat to everybody. Suppose this is the data point and this is the distance. Why it is creating a lot of problem? Suppose for this data point, the distance, suppose this is the D1. So data point D1, distance with C1 is 2 meter, suppose this 2 meter. And this data point distance with the same data point distance with the centroid 2 is equal to 1 meter. So here you can understand this data point is currently a member of C1. You see, this data point is a member of C1. But you realize after calculating the distance of this data point is more close to the centroid 2. So it is more closer to the centroid 2. It should not be a part of cluster 1. It should be a part of cluster 1. So what you will do? You will change the cluster boundary. So means it will become a part of cluster 2 like that. It will become a part of cluster 2. You will change the boundary. You should not change the data point as we have seen in earlier. Agree? Okay. So this thing is clear to everybody? Both the same distance, then randomly whatever the assignment were there, it automatically will be there. So in the machine learning, never confused. Okay, so if the distance are same, randomly it will assign to anyone. Arundhati ma'am, it's clear? Okay, so this question is applicable to everywhere in the world. When the distance are same means it will not be going to hang. So randomly whatever the cluster will be there, it will assign randomly. There is no confusion. Okay. Now stopping criteria. So you need to understand, because it iterative process, it will not go forever. It will not go the n number of or infinite number of iteration. So these are three uh, stopping criteria. First, changes means that the way I have explained, the data points are changing their membership. Means it will not be happen only with one data points. It may happen with any number of data points. Some data point will not change the memberships, some data point will change. So suppose this changing is happening, data points are keep on changing their position membership throughout the iteration. But data points movement between the cluster does not improve the cluster fit criteria. Means data points are changing their membership, but their impact is not positive on the homogeneity and heterogeneity property. These are the two objective functions. So changing the position from one cluster to another clusters are not improving the cluster fit criteria. So we should stop it, because ultimate my objective is to improve the homogeneity or heterogeneity. I think everybody agree. Second is stopping criteria may be there, the things become stable. Data point stop moving here and there. You keep on iterating, the data points are not changing their membership. You should stop it. Third condition, it many time happen, it many time we have seen the condition 1 and condition 2 never occur. Okay, so at the starting of the algorithm, we have predefined the maximum number of iteration, maybe 100. So by default, the algorithm will continue 100 time of iteration. Before reaching to this number of iteration, if condition 1 and condition 2 arises, well and good, we will stop our execution. Otherwise, we will continue to the 100 number of iteration, then we will stop it. How to change the boundary? Automatically, algorithm is changing the boundary. We have seen like this is the boundary. Boundary means what? Earlier, you have assigned this data point into the C1, but we have find the C1 is not good. We are deleting it and assigning the C2. Means we are changing the boundary. Dr. Siddhartha, it is clear? Changing the membership, whether the moment we change the belongingness of the cluster, it means we are changing the boundary. We know we don't need to keep or move the physically data points here and there. Dr. Sujata, it is clear?
Yes, sir.
Thank you. Yeah. So this stopping criteria is well understood. Okay. Then I need to go for the next phase of discussion. Numerically, I will explain all those things because the questions I am just observing, the people are very much confused and or they are understanding, they are trying to understand. That is very love to see it. So when you do the numerically or you solve the things with the help of numerical, it always be damn clear to us. So before jump into the numerical, as we know, we are talking about the distance. So there are many distance measures are there. There are many distance parameters are there. Mm, Euclidean distance is one of them. So that is a formula I have written of the Euclidean distance. So suppose two data points are there, x1, y1, x2, y2. So this is a formula to calculate the Euclidean distance. If the data points are in the multidimensional, means x1, y1, z1 are the variables. X1 may be age, y1 may be a weight, z1 may be a salary. So these are the variables. The more number of variable, easily you can extend the Euclidean distance formula. So this is the simple example. You can fit it, you can calculate the distance like that. You are not interested to use the Euclidean distance, many other distance formulas are there, like a Manhattan distance, Minkowski distance, and many others. Or you can develop your own distance formula and you can implement in the clustering algorithm. The moment you will change the distance formula, the different cluster will be there. So you should not expect, because machine learning, as the day one I am saying, it's a very dynamic, very random nature. So 2 plus 2 never be 4 always. So here the moment you will change the either the training method like in the classification or any distance matrix or any kind of activation function, any kind of mathematical function that are being used during the algorithm, you will change it, the result will be different 100%. Okay. So based on the distance matrix, you have to choose by hit and try which matrix will work in the given data set. So it also be very important to see the nature of data point. Based on the nature of data points, you have to choose smartly your distance matrix. Which is a good distance matrix? How to choose it? Again, the different discussion. I will. We don't have time to take that account. Okay. So come with me, we will solve the k-means clustering through the numerical example. Suppose this data set is given to you, very simple data set having a two features only, weight and pH value. Simple, the medicine about that, medicine weight and medicine pH value. There is a 4 data point, 1 1, 2 1, 4 3 and 5 4. These are the data points given to you. So you see and this scatter plot you apply over there. And if I say what will be the two cluster if you create, so you will say, sir, is very simple. Is question easily. This should be a one cluster, and this should be another cluster. So if as a human knowledge, as a human being, we have a knowledge, we can say these two data points are close to each other. These data points are close to each other. Suppose two clusters supposed to make. So this should be a two cluster. I think everybody agree. Okay. So now I have to see it whether the same output, whatever we are expecting, it can be given by the k-means clustering or not. Okay. So how to do it? Suppose randomly we have selected the two data points as a two centroid or two clusters. Suppose so C1. So suppose this is the one cluster. This is another cluster. I have selected having a 1 1 data point. So look, see, C1 is the one cluster. C2 is the another cluster. Okay, and we are starting with this random assignment, and whether we'll see how will happen. So what is the process you try to remember? So we start calculating the distance. First I will explain what part. This I will going to explain. Yeah. So C1 we have, C2 we have to calculate the distance of all the data points to the centroid of cluster 1 and cluster 2 also. So here you will see this is the C1 having a single data point 1 1. So centroid will be 1 1 by default. So I have to calculate whatever the data is given to you. This is the complete data set is given to you. This is data point 1 1 1 2 1 4 3 5 4. You see, this is the complete data points are there. I am representing with the matrix. So this is the matrix. So I have to calculate the distance from all the data points to this centroid. So if you try to calculate the Maclaurin distance between 1 1 to 1 1, these are the same data point. That's why distance is 0. Distance between 2 1 to 1 1, distance is 1. Distance between 4 to 1 1 is 3.61. Distance between 5 4 to 1 1 is 5. So this is the distance matrix of all the 5 data points with respect to the centroid C1. The same process we have to repeat for the centroid C2. The same data matrix you see, whatever the data set, same data set. Centroid is different. So this is 1, 0, 2.83, 4.84 are the distance with respect to all the data points to the centroid C2. Okay, so this is summary. So this is distance 1, this is distance with respect to the C2. So I'm comparing all the distance. Okay, so this data point having a 0 distance with respect to the C1, the same data point having a 1 distance with respect to the C2. Similarly, other values are there. So we have to check which value is smaller, or which data point is close to the which cluster I have to assign it. Okay, so you see over here, this is a membership matrix is given over there, the group 1 or centroid 1. So this data point 1 means is a part of cluster 1, because if between the distance C1 and C2, this is a smaller one. So it will go to the part of cluster 1. In all the other data points, second, third, fourth, distance between the to the centroid C2 is smaller. Look, 0 is smaller than 1, 2.83 is smaller than 3.61, 4.24 is smaller than 5. So these 3 data points will become a part of cluster 2. So 1 means it's a member of the cluster 2, and 0 means it is not a member of cluster 2. So these are the assignment after the first iteration. I think everybody agree? Is the assignment after the first iteration. Agree? So in the second iteration, I have to recalculate the centroid. So the group 1, it already there is a 1 data point, so the centroid going to be the same 1 1. But in the second or cluster 2, now we have a 3 data points. So how to calculate the new centroid of the cluster 2? Similarly, corresponding x value we have to average it, corresponding y value we have to average it. So these 11 by 3 and 8 by 3 is a new centroid of the cluster 2. Okay, so in the summary I have written a distance matrix. So again we have to calculate the distance of all data points to all the centroid. So this is the distance of 4 data points with respect to the C1. This is the new distance we have calculated. All the data points to the centroid C2, that is a new in 11 by 3 and 8 by 3. And we have to see the corresponding comparative distance. So this is smaller, means this yeah, so you see the assignment matrix. So this is smaller, so this data points will become the part of C1. Now see here, 1 is smaller than 2.36. So this cluster earlier was a part of cluster 2. This data point was the part of cluster 2. It will shift to the cluster 1. You see 1. So it become a member of C1. For the remaining 2 of the data points don't have any changes. So what we have observed earlier in the cluster 2 having a 3 data points, now the cluster 2 having a 2 data points, and the cluster 1 also having a 2 data points. Means during the iterative process, data points are changing the boundary. Data points are changing the boundary. So we have to keep on our iterative process. We have to calculate the new centroid. So this is a new centroid C1 by using these 2 data points. Similarly, new centroid C2 by including these 2 data points. So we have a 2 centroid C1 and C2 now. We have to again repeat the process. We have to see, calculate the distance of all the data points with respect to all the centroid we have. and we have done that distance, and the distance is written to you, Euclidean distance are there, and based on the closeness you can reassign the membership. So see here, this is smaller, that's why these two data points will be the part of C1. Remaining these two data points are closer to the C2, this is a part of C2. So what important things you have observed? The data points stop moving here and there. So earlier these two are the part of cluster 1, remaining two are the part of cluster 2. After the next whole iteration, there is no changes in the membership. The points are not moving. Means condition 2 of stopping criteria matched. So we stop moving here and there. Agree? So we have to settle down over here. We have to stop the iterative process, and these are the final cluster. So point 1, 2, 3, 4. So what was I was expecting at the beginning? 1, 2, and 3, 4. These are the one cluster. These are the one cluster. So whatever the output we were expecting, the same output given by the clustering algorithm. Thing is clear to everybody? It is clear to everyone. If you have any question, please write on the chat box, or you may unmute or ask me. Very good. So one point, thank you, Arundhati madam, thank you, Poona madam. So one point I have promised to discuss with you how to choose the correct value, almost correct value of the K. Because in the K-means clustering, the K is a value that is given by the user, and user most of the time give the wrong value of the K, or ultimately we require some scientific process uh, that will have a more confidence with the value of K. So how to do it? This process is written over there. The whole process I will explain. The method is a method. You try to understand the method are used being in the different places. So don't think this is the only the elbow method. In principal component analysis, there will also be a elbow method. So this elbow method, how it works, let me explain. So any of the diagram you can consider, don't confuse with the each other. What I'm talking about, the what diagrams talk about. The process elbow method says that this is the K, this is the homogeneity. Okay. So these are the one of the objective function. These are the number of K. So you just start with the K is equal to 0 not possible, K is equal to 1 not possible. We have to start with the K is equal to 2. Then we have to check 3, we have to check 4, we have to check 5, we have to check 6, we have to check like that. So ultimate, what it is saying, first you have to complete the clustering process with the K is equal to 2. Then independently we have to complete the K is equal to 3. Then you have to complete the clustering process with the K is equal to 4, like that, you have to continue. Where you have to stop? So once the K is equal to 2, there will be some homogeneity. We have to calculate the homogeneity, okay? So we don't have time to see over here how to calculate the homogeneity. If I try to explain homogeneity means what? Suppose this is the cluster 1 or this is the cluster 2. How many cluster you have? There are many methods. One of the method is that cluster 1 centroid is here. The distance of all the data points to the centroid, you sum it. It is called homogeneity. It is summation of all the distance of the cluster 1. Similarly, the distance you need to calculate from other cluster, then sum of the distance of cluster 2, and you sum all the distance. Sum all the distance. So whatever the value you will get, you will say it is a homogeneity. Okay, so these are the distance, summation of all the distance to the centroid, summation of all the distance to the centroid, and sum all the distance. So it come with the value that is called homogeneity. So you are plotting the homogeneity over here. One of the thumb rule is that homogeneity is directly proportional to the number of K. So the moment you will increase the number of K, homogeneity also increase. Okay, so it will go like that. it will go like that. It will go like that. Okay, like that, like that, like that. The beauty of this graph is this: is that you have to find out the sharp angle or the point. From that point, the improvement in the homogeneity is not significant. So earlier, you see the angle. The moment you are increasing the k value, it is contributing a lot in the homogeneity. But if you continue, you will find a one condition, some portion. For someone it may be here, on someone it may be here. It work. After that, it will increase or it will improve the homogeneity, but significant is not. It is not significantly improving the homogeneity. So that point, suppose for someone pointed this point elbow, because elbow means where is the elbow is here. This elbow point, where is the sharp turn. For some of the candidate or participant, elbow point may be over here. So this corresponding value will be the ideal, or it is the better value of the k. So someone may say k is equal to 4 is, someone say the k is equal to 5. It's okay in the both the cases. Okay. So this is the elbow method. Okay. This is the elbow method. It is clear to everybody? It is clear to everybody? Many of the participants asking about the attendance. I have just opened it. Please go and give the attendance. No issue. So, any question over here? In the elbow method, any question? If you have any of the question, please ask me. Okay. Last topic I'm covering. Some of the limitation in the k-means clustering is that. So k-means clustering assume a cluster have natural circular boundary. So suppose this is the data point is given to you. This data point is given to where this is the one cluster supposed to be, and another cluster should be this one. But if you apply the k-means clustering, it will create this kind of cluster. This kind of cluster. So suppose this is the data points are given to you. Okay, you see. So it will create this kind of cluster that is a totally wrong. So if this type of complex boundary, if you have, you should not apply the k-means clustering. You should go with the DB scan or distance based clustering. So Dr. Sujata have written no sir. So no sir means what? I am not getting. This link is working. Attendance link is working to you all, please. Or Sujata madam, please clarify your response. No sir means I am not getting. So no sir, maybe no doubt, I think. So attendance link not received. I have given the attendance links in the chat box where you are saying, G, where you are looking the attendance sheet. The link I have just shared over here in the chat box. Everybody here have received attendance link, or is it working to you all, please? Attendance link is working for you all, please. Yeah. Not received means what? I'm not getting. Not received, not received, not received. Attendance rate. It is there in the chat box I have written. You are not referring your chat box? You have joined late, I think so. Okay, okay. I'm again sharing. Don't worry.
Sir, I have shared it again.
Yeah, attendance I have shared. Please see it again. This link is visible to everybody. Okay, now
Yeah.
you try to go through it. Is it working or not? Please see it. Sorry for that.
Sir, it is working.
Very good, very good. Thank you, thank you. So this session is over from my side. Whatever I had planned, I have covered it. So if any of you have any of the question, please discuss with me. I have a one feedback I want to know from your side because you are attending the class. Please, tomorrow we have two classes. Okay, session 1 will be taken by Ojas. That will be a PCA. There is a session 2 that is starting from 11:45. That will be taken by myself. Now I have a two idea. So whatever you will say, I will pick up. Whether I will show the implementation of the logistic regression we have covered, but we didn't see the implementation with the data set, plus implementation of the k-means just we have seen right now with the data. I have a one way to cover that part in the tomorrow second session, or I should introduce the deep learning. It may be only introduction. Okay, so what you want, please. So I may cover either of the session. Maybe logistic regression with the data I will try to demonstrate. K-means I will try to demonstrate with the implementation, or okay, everybody directly writing about this one. Okay. Linear regression already over. Linear regression is already over. Apurva ma'am, Apur Verma ji, linear regression implementation already. Logistic. If you are talking about the logistic regression, okay. The many of the participants, I think 99% participants are looking total implementation, interpretation by using data, by using code, everything I will cover. Both I will cover. The logistic and k-means both. We have enough time to cover both the implementation. Okay. A couple of person are writing about the deep learning. So I have one answer about the deep learning because this algorithm having, okay, all the participants please focus on there. If you go to the Attal, where you have registered, there is a 2 FDP with the same name, like a robust AI. There is a 2 FDP. If you try to, you didn't see part 1 and part 2. So it is called introductory level FDP and it is called advanced FDP as per the AICTE. So this is the FDP currently you are attending from October 1 to 5. It is from 4 to 8 February 2022. So ideally you all must register in the part 2 of this FDP. Okay, so it will be the advanced version of the FDP. So I will not cover any of the topic that are being covered in this FDP. It is going to be a part 2. And the part 2 will be totally based on the deep learning. It totally will be based on the soft computing. Optimization will be there, like that. So a small announcement, if you are really interested to go into the more detailed discussion about the AI, please register from the Utter portal the part 2 of this FDP. So if you try to go to the portal, select the Chhattisgarh, and you will enter the a month like a February 2022, like that, you will find in IIITNR having only single FDP. It will listed over there. The name of the FDP will be same as it is, 4 to 8 February. It is clear to everybody? So that FDP will have a more advanced topic like a deep learning, soft computing, optimizations, many more. So Huma madam were asking for the deep learning. I will cover over there. There will be many. There will be a CNN. There will be RNN. Oh, there may be many things will be there. So that information I have shared. So tomorrow, most of the person, not all, are interested to see the implementation of the logistic regression with the data set. with the dataset, implementation of the k-means with the dataset I will cover. Where everything, what is the possible with the time limit I will cover, and I will demonstrate to you. Okay, so tomorrow going to be last day. So tomorrow there will be a quiz. I have announced there will be a quiz from 1 p.m. to 1:30 p.m. It is totally MCQ based quiz. They will have around, I think, 25 questions for a 30 minutes. And that is very simple questions, whatever the things we have covered. Okay. So certification, you try to, I think every one is interested to have a certificate. There are some couple of rules to try to understand. What are the rules? First, attendance 80% minimum required attendance. 60% marks minimum in quiz, and fill the feedback. So many of the participants think about that they have a decent attendance, they have given the quiz, they will get the certificate. Not at all. It is a AICTE rule. The feedback link I will not share. You have to log in your Utter portal tomorrow, and I think we have to see from where it is enabled. So you have to fill a feedback about FDP. There will be list of questions, and based on that you have to share your feedback. Once you fill the feedback, and then I will take around you can say more than 1 week. I will enter your attendance and marks. The moment I will enter your attendance and quiz marks, if you have already filled the feedback within a 1 day, you will get your certificate in your email, or you may download from your Utter portal. This thing is clear to everybody? I will take at least 1 week to fill up your attendance and quiz mark, but you are allowed to give your feedback immediately tomorrow. So you complete a formality from your end. You just fill your feedback completely, wait for 1 week, I will fill the marks. These attendance and marks will be visible to you all. Okay, whatever the quiz marks, attendance marks, the moment I will fill, it will be visible to you. So after 24 hours, you will get your certificate. Okay. Anything else you want to ask? Please write in the chat box. Otherwise, we should stop our session right now.
Hello, Vivek sir.
Yes, please.
Sir, I am Riya Bakhtar from Institute of Pharmacy and Research, Badnera, Amravati. Sir, we have joined the
Thank you,
meeting,
ma'am.
but our names are displayed as B.Pharm final year, B.Pharm third year, since they are saved as it is in the WebEx account.
Okay.
So when you will tally, shall I give that details to you on the WhatsApp group?
Email. WhatsApp group personally you sell me, or otherwise you write to the mail, or you WhatsApp me personally. I will take care.
Oh, okay, sir. Thank you, sir. Thank you so much.
Okay. Hope all the session from the today was informative, and we are going to end this day, and we'll meet you tomorrow. Huma madam is not able to find the part 2 FDP. No, madam, it is not possible. I think everybody will try to see it. Other participant also trying. So someone is writing they are not able to find the part 2 FDP. So they will not be named like part 1 and part 2. You go to the Utter portal, try to register in the workshop. In the workshop, you filter in February 2022. Yeah. You type the Chhattisgarh, and like if it is asking about the month or 2021 is possible, 2022 is possible or not. I know you please all the participants try to register for the next FDP in February FDP. If it is not visible to you, Please let me know. Please let me know. So you have one day. Tomorrow we may have a discussion about that, whether that FDP is visible to you all or not. Thank you. Thank you. I'm going to end the session. Thank you, participant. You all will. Yeah, Shailen Gupta is writing. Yeah, the name will be same. Robust AI. There will not be part 1 and part 2. The title of the FDP is same. Right now we are attending, and in the next FDP in February, this title is same. Because as per the AICT, we cannot change the title. Title may be like introductory FDP, the same title, advanced FDP with the same title. Thank you very much. I'm going to end the session. Thank you. Thank you.